Hello dear learners, I am Dr. Renuka Mainde, corporate nutritionist and counselor in IGNOU for their dietetics and food service management course. Learners, today we will be learning about quercetin, a dietary polyphenolic compound with potentially beneficial effect on health. Most research has focused on the antioxidant properties of quercetin, its effect on several enzyme systems and on biological pathways involved in carcinogenesis, inflammation and cardiovascular disease. So let's begin learners with objective of the present modules. Learners shall able to define and describe the chemistry of quercetin, enlist the sources, discuss the effect of processing on quercetin and describe the metabolism and bioavailability of quercetin. Learners, quercetin are naturally occurring flavonoid that function as active dietary antioxidant. These flavonoids are universal in food including vegetables such as onion, garlic and ginger, fruits such as apple and in tea and wine. All quercetin however are not equal. Certain form of quercetin such as quercetin rutinoside are poorly absorbed by body and more likely to be irritating or allergenic. Another example of quercetin is chalcone, a special hesperidin which has an exceptionally short half-life and is therefore not effective unless it is taken every hour or so. Quercetin has a basis for potential health benefits to overall health and disease resistance including anti-carcinogenic, anti-inflammatory, antiviral, antioxidant and psychostimulant activities as well as the ability to inhibit lipid peroxidation, platelet aggregation and capillary permeability and to stimulate mitochondrial biogenesis. Let's first understand the chemistry and the structure of quercetin. Quercetin is characterized as flavanol, one of the 6 subclasses of flavonoid compound. The name has been used since 1857 and is derived from quercetum, oak forest. It is naturally occurring polar auxine transport inhibitor. The International Union of Pure and Applied Chemistry nomenclature for quercetin is 3,3,4,5,7 pentahydroxy flavin 1. This means that quercetin has an OH group attached at the position 3, 5, 7, 3 and 4. Quercetin, the chemical formula is C15, H10 and O7 where C stands for carbon, H stands for hydrogen and O stands for oxygen, is an aglycone lacking an attached sugar. It is a brilliant citron yellow needle crystal and entirely insoluble in cold water, poorly soluble in hot water but quite soluble in alcohol and lipids. A quercetin glycoside is formed by attaching glycosyl group, a sugar such as glucose or rutinose as a replacement for one of the OH group. The attached glycosyl group can change the solubility, absorption and in vivo effect. As a general rule of thumb, the presence of glycosyl group quercetin glycoside result in increased water solubility compared to quercetin aglycone. A quercetin glycoside is unique by the attached glycosyl group. Generally, the term quercetin should be used to describe a glycone. Learners, let's now understand sources of quercetin. Quercetin type flavonols primarily as quercetin glycosides. The most abundant of the flavonoid molecules are widely distributed in plant. They are found in variety of foods including apple, berry, brassica vegetables, grapes, onion, tea and tomatoes, as well as many seeds, nuts, flower and leaves. Quercetin is also found in medicinal botanicals like ginkgo biloba. In red onion, higher concentration of quercetin occurs in the outermost ring and in the part closest to the root, the latter being the part of plant with highest concentration. Quercetin is also present in radish leaves, fennel leaves, cilantro and fruit like plum black. Learners, let's now understand the effect of processing on quercetin content. Preparation and storage of food can affect quercetin content. Fried or boiled food contain lower quercetin content, while boiling being the main causative factor for the reduction in quercetin level due to the thermal degradation and leaching action of boiling water. Long-term storage of food was found to change their quercetin content, while onion lose their quercetin content by up to 33% in first 12 days of storage. Quercetin level in strawberries has been shown to increase by approximately 32% when stored at -20°C for 9 months. Apart from storage and preparation, the condition of the growth of plant were found to be a factor that influence quercetin level in them. This is clear from the studies that indicate a higher quercetin content in plant exposed to greater amount of UV radiation. Peeling and trimming of onion is said to result in 39% of flavonoid quercetin loss, and greater losses were noticed while peeling and dicing of tomatoes. Learners, let's now understand metabolism and bioavailability of quercetin. The first investigation on pharmacokinetics of quercetin in humans suggested a very poor oral bioavailability after a single oral dose of approximately 2%. The estimated absorption of quercetin glucosides, the natural occurring form of quercetin, ranges from 3% to 17% in healthy individual receiving 100 mg dose. The relative low bioavailability of quercetin may be attributed to its low absorption, extensive metabolism or rapid elimination. Quercetin glycosides might be differently absorbed based on the type of sugar attached. Available evidence indicates that quercetin glucosides, like those found predominantly in onion or shallot flesh, are far better absorbed than its rutinosides, the major quercetin glycoside in tea. The glucosides are efficiently hydrolyzed in the small intestine by beta glucosidase to a glycan form, much of which is then absorbed. Quercetin glucuronic acid and its sulfuric acid derivatives were more easily absorbed than quercetin. Thereafter, its absorption is affected by differences in its glycosylation, the food matrix from which it is consumed, and the co-administration of dietary components such as fiber and fat. Thus, different sugar types and sugar group conjugation sites will result in absorption variation. After absorption, quercetin is metabolized in various organs including small intestine, colon, liver and kidney. Metabolites formed in the small intestine and liver by biotransformation enzymes include methylated, sulfosubstituted and glucuronodated form. Quercetin and derivatives are transformed into various metabolites by enteric bacteria and enzymes in intestinal mucosal epithelial cells. These metabolites are absorbed, transformed or excreted later. Moreover, bacteria ring fission of a glycan occurs in both the small intestine and colon, resulting in the breakdown of the backbone structure of quercetin and subsequent formation of smaller phenolics. Continuous intake of diet containing quercetin accumulated in the blood and significantly increased quercetin concentration in plasma and was significantly correlated to its dietary content. Quercetin is present in conjugated form in human blood whose major form is glycosides. Quercetin and derivatives are stable in gastric acid. However, there were no reports whether they can be absorbed in stomach. Studies suggest that quercetin is absorbed in the upper segment of small intestine. Among quercetin derivatives, conjugated form of its glycosides are better absorbed than quercetin. Purified quercetin glucosides are capable of interacting with sodium dependent glucose transport receptor in the mucosal epithelium and may therefore be absorbed by the small intestine in vivo. Let's conclude, learners. Hope you have understood the structure, chemistry, metabolism and bioavailability of quercetin. Quercetin is a dietary flavanol found widely in fruits, vegetable, nuts in many glycosidic form. Bioavailability of quercetin is now relatively well documented. Data is still lacking on the association of this flavonoid in the diet with respect to absorption and metabolism, as there is increased evidence that there is a little to no free quercetin in the plasma. The effect of glucoconjugates and not free quercetin must be further investigated.